Hey, good morning, everybody. This is Mr. Aynesworth. Let's greet each other properly. Good morning. Good morning to you guys. Hey, listen, we're going to get into section 9.4 here in financial algebra. And once again, I'm Mr. Aynesworth here at Great Oak High School. And we're going to get into a little lesson here on fixed and variable expenses. And so a couple things you need. Well, let's see. It means you need Desmos here. So you need a calculator here. So get your Desmos out and ready here. We, in our class here, in our school, we use Desmos because you can actually save all your work here. So go ahead and get that ready to go. Make sure you name it so you can save your work and make sure you sign into it. And so have that off to the side. Also, okay, really important here, get out your notes. All right, guess what? You guys were supposed to watch a video prior to this, and I just screenshotted some of the slides that were in the notes here, the notes that I took when I looked at it here, just to show you that, hey, guess what? You know, in the video, we go over all the different concepts that are in the lesson here. So if you get ready, all right, by watching the lesson here, it's obviously going to help you out. All right, so let's get right into it here. Let's talk about some fixed and variable expenses and show you how everything is applied. All right, so number one, all right, the fixed expenses for producing widgets. Okay, no widgets. Okay, that's just a general name for, you know, a thing that is produced. Although whether it's a Microsoft Surface pen or, you know, a pencil, it doesn't really matter what you're producing. General name is called widget. All right, so a fixed expense for producing widgets is $947,900. Okay, so that's your fixed expenses. So let's talk about it. So the fixed expenses here, all right, is equal to $947,900. All right, total. All right, the labor and materials required for each widget cost $16.44. All right. Now it says for each, so keep that in mind. So it says for each widget. All right, so that is a variable expense. Okay, so our variable expense here, in terms of per quantity here, that's going to be, it says here, $16.44 per widget produced. All right, so it all obviously depends. Your total variable expenses depends on how many widgets you sell, because it's the price of the widget times the number of widgets will give you a total variable expense. All right, so this tells me here the total variable expense is going to be equal to the price per widget times the number of widgets sold. So if you read on here, it says represent the total expenses as a function of the quantity Q produced. So you're producing Q widgets. All right, so there's Q widgets here. I know that's just the general term. If you go to business school, you'll hear that a lot. All right, so the total variable expenses is the price per widget times the number of widgets. So we obviously have to multiply those. All right, so we're going to take $16.44 per widget. All right, we're going to multiply by Q widgets. Now, if you notice here, widgets cancels out, just like units cancellation, you get $16.44 times Q. So our total variable expenses here is equal to $16.44 times Q. That's the total variable expenses. Now, it's not asking for just the total variable expenses. It says represent the total expenses. All right, total expenses as a function of the quantity Q produced. All right, so let's do that. All right, so here we go. So the total expenses, all right, is always going to be your fixed plus your variable. So if you take your fixed and add it to your variable expenses, you're going to get the total expenses. And why is that? Well, let me see. We talked about that. Let's talk about that, and let's show that here in the lesson right here. So total expenses, which is, well, in the video it's called E, right? E is total expenses, and it's equal to V plus F. So V, variable expenses. So V for variable. All right, F for fixed. All right, so you take the variable expenses, add it to the fixed expenses, you're going to get the total expenses. All right, and the total expenses is E in this case. So just remember that. All right, so let's get right back into it. All right, so what we're going to do is we're going to take our fixed and add it to the variable. So let's do that. Fixed right here is $947,900. All right, and we're going to be adding it to the total variable expenses, and that's just going to be your $16.44 times the number produced, which is Q. Okay, so you have to take your price per widget, multiply it by the number of widgets to get the total variable expenses, which obviously depends on Q, like how many you're producing, and then you add that to the fixed expenses to get the total. There we go. All right. Number 2. A widget manufacturer expense equation is E, which is your total expenses, is equal to 14 times Q plus 29,000. Remember, Q is the number of widgets that are produced. Keep that in mind. Okay. And so in this equation, it says what are the variable costs to produce one widget? Well, remember there's a Q widget. Q equals the number of widgets sold, or the widgets produced, actually. Okay, so Q is the number of widgets, and so if you're multiplied by 14, then 14 must stand for the price per widget, like we just talked about right here. So when we're talking about E is your total expense right here, so you get the total expense E. That's E right here. Okay, E, and that's going to be equal to 14 times Q, and again it's $14 times Q. Actually, I mean, just related here. So this right here is going to be your variable expenses here. We'll just make it a little simplified here. So it's going to be $14 times, per widget times Q. All right, Q represents widgets, as I just said earlier. Right here. So your variable expenses to produce one widget, the variable costs to produce one widget is going to be equal to 14, because that's the price. The quantity is Q, but the price is 14. So what they're asking you in here, what is the variable cost to produce one widget? Well, guess what? So this tells me that the variable costs for one widget per widget is going to be equal to $14. Okay? Because you always take the cost per widget and multiply by the number of widgets to get the total variable total variable expenses. And there we go. So it's $14 per widget. Okay. Moving right along. Okay, number 3, the Catania Cat Corporation. Gotta love this play on words, don't you? All right, manufactures litter boxes for cats. The expansion function is E is equal to, all right, 4.18 Q plus 82,000. Find the average cost for producing 10 litter boxes. Okay, so this is a average cost problem. Okay, and when you deal with the average cost, it always requires 2 steps. All right, 2 steps are necessary. So let's see here. Let's go to our notes here and let's figure out where that was. Okay, so go to, it looks like slide 3 and check that out. Okay. So what we want to do in step 1 is we got to figure out the total expenses given the number of items produced, and then step 2, we got to take that total expense and divide it by the number produced. So it is a 2-step problem. Okay, so let's go ahead and perform those 2 steps. Once again, just use your notes. All these problems here are just an application of what you learned in the lesson itself. Okay, so 2 steps. All right, step 1, we got to find the total cost. All right, so let's do that. So here we go. What we're going to do, we'll call this or total cost, total expenses. Now in the lesson, they use E for that. Okay, so E, this is going to be E here. So E. Oops, sorry. The total expenses we're going to use this equation here that they give us here. It says we got to take 4.8 times the quantity here, and here the quantity is 10,000. All right, this right here is going to be equal to Q. All right, so Q is equal to 10,000. All right, litter boxes in this case. All right, and we got to take that and substitute it in and figure out what the total cost is. So I got to take 4.18 times 10,000. All right, and then add 82,000 to that. So let's figure out the total expenses here. All right, now if you can't do that in your head, if you can't multiply 4.18 times 10,000 by shifting the decimal place 4 places, and then add it to 82,000. Well, then let's do it by hand. Okay, no, excuse me, using decimal, sorry. So we're going to take 4.18, all right, multiply by 10,000. All right, and again, you just shift the decimal place 4 places right there. You get 41,800, and then you have to add the 82,000, so plus 82,000 more. All right, which in this case is 123,800. So $123,800. There's your total expenses. All right, let's get back to the problem. So that's step one. There's your total expenses. Okay, I'm just labeling my results just so that you understand what's going on. All right, now step two, what we got to do is find the average. All right, now step two here, all right, it says find the average cost right there in the problem. You got to take the total cost and divide it by the number of units produced. So the average cost here, okay, let's call it AVE for average. We're going to take 123,800, and you're going to divide that by the number of units produced, which happens to be 10,000 boxes. Okay, and that shouldn't be too bad. You just shift the decimal 4 places back to the left, and we get well, it looks like $12.38, you know, per box. Okay, per litter box. That's the average cost. All right, very simple two-step process. Find the total, divide it by the number you have, and there you go. You get your average cost. Okay. And that's how it's done. Okay. Number 4, the expects function for a certain item is given by E is equal to 2.95 times Q. So you got your variable here, the variable expense plus your fixed right here. Just keep that in mind. It's always variable plus fixed. So the cost of an item is $2.95. These are in dollars. And the fixed expenses is $712,000. This is the expense function, you know, in this problem, given this business situation. Express the average cost of producing Q items algebraically. Well, guess what? We are given the total here in algebraic form in terms of Q. And we know that we're producing Q items, okay? That's your quantity. All right, and as I said over here, you take the total produced divided by your quantity. You always do that. And again, we did that here in the lesson here in the video, and that's what I'm trying to say, where you take the total expenses and you divide it by the number produced, which is called your quantity, right? The quantity produced. All right, so let's do that. Let's go back over here and let's actually do the two-step operation, just like we did in number 4. Okay, it's always a two-step procedure, but here we're given the expenses. We're given the total. Okay, it's 2.95 Q plus 712,000. All right, and the total quantity that is produced is Q items. So all we have to do to figure out the average is divide, my friends. Okay, so the average cost is you take the total. All right, the total cost, and you divide it by the quantity. In this case, it's Q. So we take 2.95 Q plus your 712,000. All right, and you divide that by Q, which is the quantity. And that's it. And that's how it says. It says do that or express the average cost of an item or producing Q items algebraically, all right, in terms of Q. So if we knew what Q was, all we do is just substitute it in there and then solve and simplify, and then you're good to go. All right, number 5. The Mizzy Corporation has created a demand function for one of its wrench sets. It expresses the quantity demanded in terms of the wholesale price P, and it was created by surveying retailers and using a linear regression. Ooh. You know, the demand function is Q, okay, and their expense function is E. Express the expense function in terms of P. In terms of P, the price. Now, P stands for price. Okay, excuse me for a moment here. I've got a little computer glitch here. All right, let's see if we can continue here. I'm having some computer difficulties here, but I'm going to do my best to continue. All right, so what we need to do is to express the express function in terms of the price, I need to substitute my demand function here into, believe it or not, this into my expense function. All right, because I want to get the express function not in terms of Q, because it's in terms of Q right now. I want to get it in terms of P. All right, so what I do is do a little substitution here, and I simplify it, if that's possible. It's definitely possible. I've got some computer issues here. So what I need to do is I need to take negative 98p plus 5,788, and I needed to substitute it right in through here and for Q. All right, so here we go. I'm going to try to do that. All right, so E here is going to be equal to 28, okay, not 28, 23, times times P plus the 5,700. Then add the constant right there plus. All right, now you might want to use a calculator here because the numbers are getting kind of big, but what we need to do is we just need to distribute through the 23. All right, so we're going to do that, assuming I can get my computer to agree with me here. So I'm going to distribute through here twice, and I've got to multiply the 23 times a negative 98. That's why I brought my little Desmos over here off to the side. So I'm going to take 23 times a negative 98. And notice it gives me about negative right there, negative 2,254. Now that's times P. So let me work on this side over here. So let's go off to the side and try to simplify this here. So here we go. So you get negative 2,254, and then I got to take 23 times 5,788. All right, so let's do that. So 23 times 5,788. Notice it says 100. Oh my God, check this out. Okay, and then 133,000. So plus 133,124. All right, plus this constant hanging around, which is 68,000. So what we need to do is simplify that. So I get negative 2254 times P, and then I've got to add these two constants right here. So I need to take 133,124, and I need to add it to the other constant, which is 68,000. All right, and notice I get 201,124. So I get $201,124. All right, and that, my friends, is your expense function. Let's make this a little bit bigger here. All right, in terms of P. All right, this is E in terms of P. It says E equals negative 2254P plus 201,124. That's what it means to be in terms of P. These little words right here, in terms of P. Not in terms of Q, but in terms of P, the price. And that, my friends, is number 5. All right, we're going to do a lot more, and I'm going to do a lot more in my next little video here, since I'm having some tech problems here. It's not going too well. And I'll see you in part 2 of my video. All right, see you then. Bye-bye. Hey everybody, this is Mr. Aynesworth. We're going to continue on with our lesson here in financial algebra here in chapter 9, section 4, talking about fixed and variable expenses. In the first part of the video, I stopped at number 5 and I said, go ahead and try number 6 since they are similar. Okay, so I'm not going to go through number 6. We're going to jump right into number 7. Make sure though you have your notes handy, like I am showing you over here off to the right. I have the notes from the video. And also have Desmos handy, because you are going to need a simple calculator to do just some basic calculations from time to time. So just keep that in mind. All right, let's jump right into number 7. Here we go. So Wexler's manufactures widgets. All right, widget is a general term for something that is produced. It could be a pen, a calculator, a computer, a phone. It could be anything. Okay, it could be a glass. It doesn't really matter what it is. It's just a general term. They create a monthly expense equation of all the expenses in 1 month of manufacturing. The expense equation is given. All right, so let's highlight that. We know what the expense equation is, and we know that the expense equation talks about how we take the variable expenses right here and add it to the fixed expenses. So just looking at this equation, I know that Q stands for quantity here. So Q represents quantity. There, I'll put it right here. The quantity of the widgets here, quantity of widgets in this case. All right, and I know that for each widget, it costs $2.10 per widget. I know that in respect to the cost, okay? Now that's the cost, not the wholesale price. That's different. It says they plan to sell the widgets to retailers at a wholesale price of $3.50 each. So they cost $2.10 to produce, but they sell it to the retailer for $3.50 each. So that's different, okay? All right, so they plan to sell. They already read that. So the question here says, how many widgets must be sold so that the income from the widgets is equal to, look at that, equal to, all right, the expense. Okay, so right away we have an idea here. We want income right here, income from the widgets to be equal to the expense. You know, how many widgets must be sold so that the income from the widgets is equal to the expense of producing them, okay, and round to the nearest widget. Okay, well, we need to figure out the income first, okay, so the income produced. So the income from Q widgets. So from widgets here. Okay, so we know that there are $3.50 each for wholesale, right? $3.50 per widget, $3.50 per widget as a wholesale price. So if I take $3.50, all right, per widget, and I multiply that by the number of widgets, which is Q, right? Q is the quantity of widgets. So Q widgets here. Notice that if you simplify a little bit and cancel out the units, we get 350 times Q. And you always take the price per item times the number of items produced or sold to figure out the total, okay? And so in this case, right here, this is going to be equal to 350 times Q. That's the income from the widgets at this wholesale price. Now we want the income equal to expense. So what I'm going to do is I'm going to take 350 times Q right here. Okay, that's a Q. And set it equal to the income or the total expenses, which is $2.10 times Q plus this fixed cost of $7,600. All right, I'm not going to question that. They give that to us. That's your expense equation. And as all expense equations, it's always variable plus fixed. Well, to solve this, you just simply subtract $2.10 Q from both sides. Okay, so just do some basic, simple algebra here. And 350 minus 210 is $1.40, so we get $1.40 times Q is equal to 7,600, and then all you do is divide by 140. All right, I'm talking about $1.40. So that's why I said get a simple calculator handy, because you will be making some simple calculations. So let's take 7,600, all right, and let's divide it by $1.40. All right, so notice it says 5,428.57. We have to round up here because it says round to the nearest widget, because these are things, right? And we want to round this up. So instead of 5,428.5, we say 5,429. All right, so 5,000. So Q now, this tells me that Q is equal to 5,000. Oh, I just forgot my answer. 400 here. All right, 429 widgets. All right, and there you go. Okay, so that's how many must be sold. So the income from the widgets is equal to the expense. All right, just set them equal to each other and solve for the unknown. Okay, now part B, it says if the company sells 2,900 widgets, how much money will they lose? Well, let me see. What does it cost to produce? What's the wholesale cost for 2,900 widgets? I don't know. Let's find out. Okay, so the wholesale cost is going to be, well, let's start off with the price per widget here. So it's going to be $3.50 per widget, all right, each. So it's per widget here. All right, and we're going to sell 2,900 of them. Oops, I'm going to put the units in here. So let me do that. I always like to be exact. And notice that widgets cancel out and you get dollars, right? So we need to multiply 2,900 times 350. What is that? And so do the arithmetic here. All right, take $3.50 times by 2,900 because you're producing or selling 2,900 of these guys. And guess what? We have a total of $10,150 income brought in from selling this number of widgets. Put a dollar sign on that. Okay, so what else? Well, what we need to do is figure out, all right, the total expense for that, right? What's the total expense? So let's work on that. So total expenses here, given the equation up there, is going to be equal to, all right, 210 times Q, so $2.10 times the 2,900, all right, plus this fixed cost of 7,600. And so what we want to do is type that in and see what it is. This is the cost, the total expenses. So $2.10 times 2,900, all right, and we're going to add the fixed costs of 7,600. And notice it says $13,690. So 13,000 and then $690. That's what it takes to produce these things, okay? And so what we want to try to figure out is like how much money will they lose? They're bringing 10,150 in, but it costs $13,690. So they're obviously lost, right? So what is the loss? Well, let's figure it out. So the loss is equal to the expense here, $13,690, minus the money that's being brought in, which is $10,150, right? And what would that be equal to? All right, and so let's figure that out too. I probably switch the order there to make it negative, but that's okay. All right, so 13,690. All right, minus the money brought in, so $10,150. All right, is a total amount of $3,540. So they lost $3,540 because they didn't bring enough money in. All right, so let's write that out. So $3,540 loss. Well, that's not good. All right, so let's give it an unhappy face right there. Not good, all right? If you don't bring in enough revenue to cover the expenses, you got a problem. That's actually a negative number, okay? So really, technically, I guess I should have thought revenue, $10,150 minus $13,690, which would give you a negative number here. So I should switch these two. Sorry about that. So should have switched those two, come up with a negative value. All right, money brought in, revenue, okay, in this terms from the wholesale cost, minus your expenses right here, which is greater, obviously, all right, gives you a loss of $3,540. Not good. All right, number 8. All right, what is number 8? Say. Okay, so this one here, let's get organized here. So for number A, it says find the break-even point of the expense equation, all right, and the revenue equation. Okay, so underline this right here, the break-even point. Now the break-even point is where the expenses equals the revenue. So that's a major concept right here. So let's write that down. The break-even point is where the expenses equals the revenue. All right, so what we want to do is set them equal. All right, so let's do that. So 6.25 Q, so right there, plus this big number here, 259,325, and that's going to be equal to the revenue, which is 12Q. Well, we want to solve this equation, so you got to gather out the variables on one side. So let's subtract and bring common terms off to the right. Okay. And then what's going to happen here, and let's go down here so we have a little bit more room. We're going to have 259,325 is equal to 12 minus 6.25. That's going to be 5.75 times Q. Now again, if you're using a calculator here, just enter it in, right? So you take 12 here, 12 minus, right, 6.25, and notice, whoops, that was the wrong one. Got those a little mixed up there. I should have went down to the other line here. So 12 minus, all right, 6.25, and you'll notice it says 5.75. Well, at this point, we want to divide by your constant, right? So let's do that. So at this point, I need to take 259,325 and divide it by 5.75. And when you do that, you get about 45,100. Okay? Okay. So Q here, 45,100. All right, and that right there says break-even point. So a quantity of 45,100 needs to be produced in order to break even. That's what it's saying to you. Okay? Okay. All right, so number 9. Let's move on. Because we're cruising, man. We're cruising. All right, number 9 says the NFW. That's funny. I'm sorry. That if you knew what I was thinking, that's funny right there. The NFW Corporation produces a product with fixed expenses of F dollars and variable expenses of V dollars per item. Okay, so right away they already told you two things right here. So you know the fixed expenses is F dollars, and you also know variable expenses is V dollars per item. If Q represents the quantity produced, write the expense equation. So remember, expenses is equal to variable plus fixed every single time. Okay. So when you do that, you just got to add the two. So the variable expenses, the total variable, you got to take the cost of it, which is V dollars per item, and multiply it by the number of items. Okay, so this is going to be V times Q. All right, the cost per item times the number of items, which is Q. It says Q represents the quantity. All right, plus the fixed expenses, which it says is F. So the total expenses equals VQ plus F. It's that simple. Okay, and if you wrote it as F plus VQ, that's the same thing, guys. Okay, because the order doesn't matter in addition. All right. Number 10, the Burden Corporation manufactures rackets. Okay. The rackets have the expense equation as follows. Okay, so this is the total expenses right here. Okay, so let's highlight that because that's obviously important. All right, E always stands for your expense equation. And what is the average cost? And remember, the average cost we did earlier. Okay, so let's go back up here to what we did earlier in number, let me see, what number is it in? It's in number 3. All right, it was a 2-step problem. We take the total cost or the total expenses and we divide it by the quantity. All right, so we find the total expenses, and then step 2, to find the average cost, you take the total expenses divided by the quantity, and you get the average cost. Okay, well, let's do that here. So the average cost, which is what they want you to find, is equal to the total expenses, which we're given right there. Okay, it's right here. All right, divided by the quantity. So let's do it. Okay, it says it produces X rackets. There's your quantity right there. So we're going to take the expense equation, RQ plus F right here, and we're going to divide it by the quantity. And the quantity is X right here. It says it's producing X rackets. Okay, so you got to divide it by X rackets. Well, the question is, what's the quantity? Okay, and Q is quantity in general. So in this equation right here, this right here I'm talking about, all right, Q represents quantity. Q equals quantity. All right, but it says it's producing X rackets. So really, Q is equal to X. All right, so what I need to do is just substitute in Q for X, and then I'm all set, ready to go. All right, so since Q is equal to X, I got R times X now. Okay, remember, Q and X are the same thing, right? So all I did is I substituted in, no big deal. All right, and I add it to F and then divide it by X. Okay, and there we go. And that's it. So we have the average cost in terms of R, X, F, and X. Okay, or just actually R, X, and F. And that's it. All right. Okie dokie. Let's do one more here. I'll do one more, and you guys should be able to do the rest, okay? Because it's pretty much all the same thing. It's just different problems. All right, and there comes to a point where you guys have to try something on your own, and then work with other people instead of just listening to me, okay? Because who gets better when you listen to me? All right, usually me. Okay, so because I'm doing it. So here we go. So the DeMonte Corporation invented a new type of sunglass lenses. Okay, so we got some lenses here. The variable expenses are $12.66 per unit. Okay, so that's obviously important. So we know a variable cost right there. It depends on the number of units sold to determine the total expense right there. And we're also given, check it out, we're given a fixed expenses, okay? That's fixed. There's all kinds of fixed expenses in business. So it says, how much does it cost them to produce one lens and then 1,500 lenses? Well, okay, so let's first understand this right here. Okay, so what we want to do first is understand that let's start off by writing an expense equation here first, okay? Let's just go back to basics. Okay, I like to go back to basics. So total expenses, okay? So expense equation here. Total expenses is always equal to fixed plus variable, all right? Fixed plus variable. Now, it doesn't matter the order right there, but it's always fixed plus variable. All right, and so if we write a little equation here, E for expenses is going to be equal to the fixed, which they give it to you, all right, which is $111,200 right here, all right, plus the variable expenses. Well, what is that? Well, if we let Q equal the quantity of whatever we're dealing with here, which we're dealing with lenses, right? Q equals the quantity of lenses. Then the variable expenses has got to be $12.66 per unit, all right, times Q. So $12.66 times Q. All right, you always take the price per unit times the number of units. In this case, the number of units is Q. So we have an expense equation. Okay, that's the first thing. And then I start with that first because when in part A right here, it says if, how much does it cost right here to produce one lens? Well, how much does it cost E to produce one lens? Well, 1, that means Q is equal to 1. So here we go. So if Q is equal to 1, all right, one lens, that means that the expenses has got to be $111,200 plus, right, $12.66 times 1, right, because Q stands for 1. All right, so what is that? Well, you just add 1266 plus the 200. Right, so you're dealing with $111,000, all right, $212.66. Just do the arithmetic in your head. You're just adding $12.66 to the 200 and then add it to the 111,000. All right, that's if Q equals 1. But the question says, what happens if Q equals 15,000? So I'm going to do another one up here. So if the quantity is 15,000, all right, what are the expenses? Well, you're going to do the same thing. You got to take 111,200 and add it to $12.66 times the quantity, which is in this case $15,000. Now, in this one here, you might want to use a calculator, maybe. All right, so let's do that. All right, so let's enter this in. All right, so here we go. So 111,200. All right, plus $12.66 times 15,000. So notice it's a pretty big number, right? So $301,100. All right. That's what it's going to cost to produce 15,000 lenses. All right. So what I did first up there was I wrote the expense equation first, defined my variables, and then I applied it. Like Q equal to 1, find the expenses. Like Q equal to 15,000, find the expenses. Pretty straightforward. So this is the key, right? You have to be able to write an expense function and understand, what the variables mean. Q is always the quantity. All right, part B, express the expense function algebraically. Well, guess what? I already did that. I think this part B should have been first, okay, personally. Okay, so I'm just going to rewrite it here. This should have been first, in my humble opinion. Okay. All right. And it says, what is the slope? Well, the slope right here is whatever is being multiplied by your variable, because this is in slope-intercept form. So I'm going to rewrite this. This is 12.66 times Q plus 111,200. And this looks very, very similar to the old famous equation mx plus b, doesn't it? Where m is your slope. So this right here, there's your slope. And that's equal to $12.66 per item, in this case, per lens. Okay, per lens. And so it says give units to use. Well, units is per lens. So it's $12.66 per lens. And if you want to write it like that, you would write it $12.66 per one lens. All right, that's what it means. That's what the slope means. All right, it actually happens to be your unit price. Okay, let me write that down to unit price. Okay, price per unit. Unit price, price per unit, same thing. Okay, part C. If the slope is interpreted as a rate, give the units to use. Okay. I basically just I just detailed that out. So the slope is interpreted as a rate. Okay. Well, that is what I just said. Slope is $12.66 per lens. Okay. So this part right here again has already been detailed out. Let's go to part D. All right, because I don't want to repeat myself too much. D is the average cost. What is the average cost to the nearest cent? Okay, producing 15,000 lenses. Okay, well, we should know how to do that. So let's work on that. So we take the average. To find the average cost, we take the total cost, all right, and divide it by the total quantity. Okay, so we already did this in part A. So we know the total cost for producing that is $301,000. All right, $100. Okay, we're going to take $301,100 and divide it by the quantity, which is 15,000. Okay, so once again, bust it out. So 301,000. Okay, 100 here, divided by 15,000. And that will give you 20.07. Okay, so 20.07 and dollars per lens, okay? Per lens. There we go. All right, what is the average cost of producing $17,000 lenses? Okay, so here we got to be a little careful here. You can't take the previous results because the previous result in part A deals with a different amount. So I got to find the total expenses first. Okay, so I got to step this one out. So here we go. So we're going to take the variable equation or the expense equation above here and use it. Okay, so I'm going to take this and I'm going to use it down here too as well. Okay, so I know that the fixed expense is 112,000. Oh no, excuse me, 111,000. All right, 200 plus. All right, $12.66 times $17,000 in this case. So there's my step one. So let's figure out the total expenses. So just type this in: 111,000. All right, 200 plus $12.66 times 17,000. All right, so notice that that's a pretty good sized number there. So 326,420. So 326,400. All right, that's step one. Now step two, we got to divide that by the total number, which is 17,000. So the average cost in this case would be to take 326,400 divided by 17,000. All right, and what would that be? Well, so let's figure that out. So 326,400 divided by 17,000. And so it's about $19.20 per lens. So $19.20 per single lens. Okay, rocking and rolling. Okay, one more to go. As the number of lenses increases from 15,000 to 17,000, did the average expense per lens increase or decrease? Well, if you just look at the numbers here, we went from $20.07 average, all right, to $19.20. So it decreased here. So it decreased from, all right, $20.07, all right, per lens, all right, to $19.20 per lens. So what would that be? That would be an 80, if you subtract the two, that'd be an 87% decrease. So negative 80 cents per lens decrease. All right, if you just subtract the two. And I said negative here because it's a decrease instead of an increase. So if you take $19.20 minus $20.07, you're going to get negative 87 cents. Okay? Okay. All right. Now there are a few more. Okay. Oh, well, we should probably do a few more. Okay, so I forgot number 13 is kind of new, so we should do that here. So let's look at this here. Let me just think. Should we do 12? Well, okay, so let's just keep going. All right, so the expense equation of a new business venture is given. Okay, so let's highlight that. We're given the expense equation. Okay, if the owners have $100,000 to start up this operation, what quantity can they produce initially? Keyword initially. All right, if they spend all, keyword all, of their money on production. Okay, so basically expenses, if they take all of this $100,000 and it's equal to all these expenses, what quantity Q, okay, would make that happen? All right, so Q is equal to question mark if 100,000 would be equal to $4.55 times Q plus the fixed expenses of 28,500. So what does Q have to be? What can Q be? How many can they produce? So they use all their $100,000 on the expenses to start up their operation. So what we need to do here is just solve this equation here. We got to subtract, all right, 28,500 on both sides. Just do a little simple arithmetic here. All right, and you got to figure this out. And if you can't figure it out in your head, no big deal. So just enter in 100,000. All right, subtract 28,500. All right, you get 71,500. So we get 71,500, and that's going to be equal to 4.55 Q. So you obviously divide by 4.55. So we're going to take 71,500 and divide it by 4.55. Okay, and we get about 15,714 units. Now it says round to the nearest 100 units. So I'm just write this down. So Q is equal to 15,714 units here, but it says round to the nearest 100, right? So if you want to do that, that's pretty simple. Okay, Q must be equal to 15,700 units. All right, that's what they can produce, all right, before they run out of all their money, okay? And they'll use up all $100,000. And then after that, they're going to have to get, they're going to have to get some contributors, right? Some donators maybe. Or they're going to have to just work harder to get some more money to produce some more things. Because you know what? To make money, it takes money, okay? It takes money to make money. That's what I meant to say. Okay, number 13. Big one right here. Okay, so let's deal with this one here. So here we go. So the graph E shows, the graph shows expenses E. So let's this label here. So we got expenses. It's expense function here. We got a revenue function here. All right, and at several levels of quantity produced. Okay, what are the coordinates of the break-even point? So the break-even point is where expenses equals revenue. All right, so let's make a little note here. So the break-even point. Okay, R is equal to E. Expenses equals revenue. So expenses equals revenue. Okay, that's the break-even point. So what is that? Well, what are the coordinates? Well, how about m comma k? So this is m comma k. Just read the graph. Okay, so let me highlight that. Okay, so you got the coordinates of the break-even point. That's where revenue equals expenses. All right. Now it says if you, this is part B, if units are produced, will there be a profit or loss? Okay, so let's go to U. And let's draw that vertical line. Okay, so I'm going to do that. So U is about right here. And I'm going to draw a vertical line right up from U. Just go straight up. Okay. Now notice that U hits the revenue equation at this point. So go to the left. And let's call that, let me see, that's revenue. So that's R of U. Okay, R of U. And it hits the expense equation right here. And if you go to the left, right here, this represents expenses in respect to U, so we call that E of U. So notice that E of U is higher than R of U. Okay, so notice, okay, E of U, it's just a point, okay, is greater than R of U. So I'm going to use a greater than symbol, so greater than R of U. So the expenses is, your expenses here are greater than the revenue. Just notice that your expenses are greater than revenue. In fact, let me put that in words now. So expenses are greater than revenue. All right. And because of that, all right, there's going to be a huge loss because what's happened is you're spending more than you're making. Okay, that's what it means. If your expenses are greater than your revenue, the money brought in, then you're losing money. All right, so it represents a loss. Okay, you'd never want your expenses to be more than the money that you're bringing in. Okay, now it says in part C, compare, all right, compare the profit made if W units are produced to the profit if T units, compare the profit if W units are produced to the profit if T units are produced. Which level of production yields a greater profit? How can you tell? Okay, this is a big question. All right. Okay, so here we go. So I'm going to go W now. So I'm going to go wherever W is on the x-axis. Okay, and I'm going to go straight up, and I'm going to draw a vertical line. All right, now it hits the expense function here at this point. Let's call this at point A so I can talk about it. And it hits the revenue function at point B. So wherever at point A, right here, goes straight to the left where it meets the y-axis, okay, which is your dollar signs, right? These dollars are on the vertical, and then quantity is on the horizontal, okay? Q stands for quantity. Obviously, the dollar sign up here at the top means money. All right, so this point right here is E of W, so E of W, okay, and then at point B, go straight to the left. All right, and this is the revenue function. So at point B, you hit the revenue function. So that's called R of W. And notice that R of W is bigger than E of W. Okay, and the distance between them is the actual profit. So the distance between these two is the profit. Revenue minus expenses equals profit. Okay, let me write that down. So profit is equal to revenue minus the expenses. So in this case, our first scenario here at W right here, the profit is equal to whatever R of W is, okay, minus E of W, all right, at point W, whatever that is. And it's whatever this distance is between these 2 points. All right, now let's take a look at the a different case. So it says compare that with T. So T, you go straight up. So you draw a vertical line at T here. So go straight up. Okay, and notice that it hits the expense function right here at C, and it hits the revenue function at D. Okay, I'm just using different letters so I can differentiate the two. So notice that the difference between B and A is less than the distance from D and C. So if I did the same thing, and it's getting a little cluttered up here, but I'm going to do my best here. At point C, if you go to the left to figure out the monetary amount here, and you go at C at point D, go to the left. That distance right here between the two is the profit, okay? So the profit at point T, profit at T, would be equal to the revenue at D, which we call R of D, right, minus the expenses at C. Okay, excuse me, not D. I'm sorry, T. So R of T minus the expenses at T. And notice, and you can just think of it as a D minus C in terms of points here, because it's definitely easier to see using just letters. So on the graph, it's D minus C. Over here on the previous one in green, okay, it's B minus A. So you can think of that, B minus A. And notice that the distance between B and A is greater than D and C. So I can see that the profit at W is higher than at T. I can see that, okay? So to answer the question here, it says compare the two profits, right? Profit if W units are sold compared to T units, which level of production yields a greater profit? Well, W here, okay, as I said earlier, W, the distance between B and A here in green, is greater than D and C, so W yields the greatest profit, okay? So W, okay, yields, which means produces, the greatest profit. And that's the answer to part C. I can tell, it says, how can you tell? I was just talking about that. The distance from B to A is greater than D to C. Okay, and we're talking about dollars here, guys. Dollars. Okay, on the graph, because the vertical is dollars and the horizontal is quantity. And that is how it's done. All right, you guys can do the rest here. And I went through the majority of the lesson here. You guys finished 14 and 15. And if you have some more questions, well, guess what? You can see me in class. Okay, this is Mr. Aynesworth here. Once again, I'm at Great Oak High School in financial algebra. Hopefully that helped you out, and we'll see you soon. Take care.